Okay, so we're going to start the last unit of quadrilaterals. It's called, we're going to prove things using coordinate geometry. And the idea is you're going to use, we have the 4 points of a quadrilateral, and we're going to determine exactly what type of quadrilateral it is. We're going to prove, so I'm going to ask you, prove that this quadrilateral is an isosceles trapezoid. So the idea is, first, you're going to plot the points. Let's see. So first, you're going to plot the points. Second, you're going to take a journey. You're going to take a journey. Third, you're going to find the slopes and the lengths of the sides. And then fourth, we're going to make the proof. We're going to do a proof. Okay. So how are you doing this? It's very straightforward. You're going to take a piece of graph paper and you're going to plot these points. 1, 9, 5, 12, 11, 4, 3, negative 2. Now, usually when we tell you to take a piece of graph paper, and immediately kids, they just write it in the middle. But we're looking at these, I want you to say, you know what? I can put the axis wherever I want. I want you to notice that all of these numbers are positive, except for that negative 2. So instead of writing your axes like this, maybe instead, you want to draw your axis more like this. Because once again, I need high numbers. I need my 12 and my 9, and I need my 11. So I need a lot of positive space, but I don't need that much negative space. All I need is this 3, negative 2. So it's okay to write your axis just like this, okay? So let's begin. Now, I don't have a graph. I'm not able to project my graph onto the screen because the light reflects off of it. So I'm gonna have to do a basic sketch. You have graph paper. So once again, here's the points. So here's my graph paper. And here's my axis, okay? And so I've done it already. So I'm gonna plot the 4 points. The first point is, what's the first point? 1, 9. So I'm gonna make graph paper. You never ever make your own graph paper, ever. You get a piece of graph paper and you do, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2. Okay, the first point is 1, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. The next point is 5, 12. 1, 2, 3, 4, 5. This is 9, 10, 11, 12. The next point, 11, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 4, kind of right there. And then the last point is 3, negative 2. 1, 2, 3, 1, 2. Okay, so 3, negative 2. Okay, now let's connect the points. We can see the quadrilateral here. I take my ruler and I connect here, connect it here, connect it here, and connect it here. And so what you're going to be asked is, you're going to be said, so the idea is prove that ABCD, assuming that these, so this is A, this is B, this is C, D, prove ABCD is an isosceles trapezoid. Is an isosceles trapezoid. Okay, so first I'm going to do the proof, and then we're going to go over a couple of rules, and then I'm going to let you work on the proofs that I'm going to upload. Okay. Well, step 1 is plot the point. Step 2, take a journey. Well, what do I mean by that? Sorry, let me get my cat. We're going to start at A, and we're going to go from A to B to C to D. Now, if you think about it, how do we move? How do we move around graph paper? You say, well, you can only go up or down, to the left or the right. So you know what? On my graph paper, I'm going to go up, da-da-da-da-da, da-da-da-da-da. Next, I'm going to take a journey from B to C, over to the right, and down. Can you see that? Perfect. What's my next journey? Well, from C to D, go down. Let's see. And then over. And what's my last journey? Well, over 1, and then up. Okay, well, let's identify this journey. You know what? Let me use the pink pen. Usually I use red, but there we go, that's better. Pink is much better. Okay, well, I figured this out. So the idea is you're just counting squares. That's it. You're just counting squares. So what's the journey? Well, let's start our journey. Well, to go from A to B, I have to go up 3. Sorry. I had to go up 3 to the right 4. Okay, what's my journey from B to C? Well, I have to go plus 6 and down. So down in geometry is -8. How did I go from C to D? Well, I had to go down, so it's -6. And then I had to go to the left. Remember, going to the left, that's also negative. And you're literally counting the squares. 1, 2, 3, 4, 5, 6, 7, 8. Now the last journey. How do I get from D to A? Well, 2 to the left and 11 up. Nice. Well, we have now we're done. Next, we're almost done. Sorry. The last thing I insist that you do is that you identify the slopes and the distances of the 4 sides. Well, once you have the journeys, you have all this information. So let's get this down. What is the slope of AB? Well, the slope is rise over 1, run, 3 over 4. What is the slope of BC? Well, 6, let's see. Down to the right 6, down 8. Right? This is a decline, so it's down 8 to the right 6. What's going on from C to Z? Down 6 to the right 8. And last but not least, what's the slope of DA? Well, 2 to the right, 11 up. Remember, so the rise is the 11, change in Y, and the change in X is -2. Now, the last thing is, how do I find the lengths? Because we know when we're talking about rhombuses or isosceles trapezoids, I need to be able to prove that the lengths are congruent. Well, this is easy because, I'm sorry, I'm looking at the wrong side. Sorry about that. How do I find the length of AB? Well, you know what? This is Pythagoras, because what we've done is created a bunch of right triangles. The distances here are the hypotenuses of the right triangles. So it's simply AB is the square root of 3 squared plus 4 squared, 9 plus, now you should remember this. This is a 3, 4, 5 triangle. What's the length of BC? Well, BC is equal to the square root of 6 squared plus 8 squared. You might say, Mr. Adler, what about the negative number here? Well, we're squaring it. Remember, A squared plus B squared equals C squared. And so I'm squaring it. So you know what? I'm leaving it off. I should write it in there, But you know what? I'm lazy. 6 squared is 36. 8 squared is 64. 36 plus 64 is 100. The square root of 100 is 10. Next, what is the distance of CD? Well, you know what? It's the same numbers. Yeah, these lines are different directions, but it is the same number. And what is the length of AD? Well, it's the square root of 11 squared plus negative 2 squared, which is the square root. Let's see, 11 times 11 is 121. 2 squared is 4, the square root of 125. Now, you might say, do we have to, simplify this or, reduce it? You know what? I know just by inspection that the square root of 125 is not 10. It's not 10. It's not 5. So I'm going to leave it because we know that the only thing I'm going to be asking you is, are these two things equal? And you're just going to say, no, like this is clearly not equal to that. Now, let's get to it. First of all, how do I prove something is a trapezoid? Well, if something is a trapezoid, I have to prove that two sides are parallel and the other two sides are not parallel. And the legs are not parallel. So, let's see. Oh, sorry. Good. So, my first statement. I'm going to AB is, let's see. So, the slope of AB is equal to the slope of CD. Now, I'm expecting you guys, because you're advanced math students, to recognize that 3/4 is equivalent to -6 over -8, right? Therefore, AB is parallel to CD. Okay? Now, because it's a trapezoid, we have to show that the legs are not parallel. And so, once again, how do we show that two lines are parallel? If their slopes are equal. So, let's see. I need to prove that the slope of AD is not equal to CD, and we can clearly see that the slope of AD is clearly not equal to the slope of BC, right? 11 over 2, -2 is clearly not equal to -8 over 6. Therefore, AD is not parallel to BC. Well, because we show that these two lines are parallel and these are not, ABCD is a trapezoid. Okay. Now, the last thing is, let me move my computer screen. The next thing is, how do we show that it's a right? Oh, I'm sorry. I apologize. I'll correct that out of the video. A right trapezoid. I apologize for that. I will correct that earlier on. How do we show it's a right trapezoid? We need to prove that these two sides are perpendicular. So, how do we show that two lines are perpendicular? Well, the slopes, it's like that flip it and negate, but the easy way is, if the product of two slopes is -1, then the lines are perpendicular. So, let's see. The slope of BC times the slope of CD is equal to, what's the slope of BC? -8 over 6 times -6 over -8, that equals -1. Therefore, BC is perpendicular to CD, and therefore, ABCD is a right trapezoid. Now, so we just proved that ABCD is a right trapezoid. Once again, plot the points, take your journey, write the slopes, change in y over change in x. Once again, don't get nervous. Once again, these lines are either increasing or they're decreasing. Next, find the slopes and the distances, and then start writing statements. Now, what are these statements? So let's move the screen over here. That's so weird that, okay. Couple of rules, very straightforward rules. Very straightforward rule. Parallelograms. I might say, prove ABCD is a parallelogram. What you need to do after you plot the points, after you take the journey, after you find all the slopes and distances, is simply show both pairs of opposite sides are parallel. So once you have all the slopes, you're going to say, this side is the slope of the first side is parallel to the other side, and then you're going to show the other pair of sides have equal slopes. Therefore, you have a parallelogram. What's the next thing I can ask you? I can ask you, prove something is a rectangle. Okay, well, first, you have to prove it's a parallelogram. And then second, you have to show one pair of consecutive sides is perpendicular. Show one pair of consecutive sides is perpendicular. That's it. Just, once again, you proved it was a parallelogram. All you have to do is just prove these two sides are perpendicular. And we saw that the product of the slopes is -1. You have a rectangle. Next, rhombus. Or prove the diagonals are congruent. Prove the diagonals are congruent. That's a little more work. Can you see that? That's a little more work if you want to do that. But you know what? Once you found all the slopes and the sides, you don't need to do that. Let's take a look at the rhombus. What do you think about the rhombus? Well, first thing I have to prove it's a parallelogram. And then it's clear. Well, you already, I'm sure some of you would say, hey, Mr. Adler, if all the sides are congruent, which you figured out over here, it's clearly rhombus. Absolutely. Just write a statement that all the sides are congruent. I would want to see something on the paper that's literally like AB is congruent to BC, is congruent to CD, is congruent to AD. I would want to see something like this, and it would say, because all the sides are congruent, we have a rhombus. Last thing, square. Well, a square is very straightforward. First, what's the first thing you need to do? Parallelogram. What's next? Rectangle. Last, rhombus. Once you've gone through these, you can either say square. I proved it's a parallelogram. I proved that all the angles are actually, because I proved one pair of sides is a right angle, all the angles are right angles. And then lastly, all the sides are congruent. Therefore, we have a square. What else? Trapezoid. How do we prove something's a trapezoid? How do we prove something's a trapezoid? Well, once again, you have to prove one pair of sides is parallel, but you must show me that the other pair is not parallel. Show one pair of sides is parallel and the other pair is not parallel. Next thing, isosceles. Trapezoid. Isosceles. Trapezoid. First, you have to show me it's a trapezoid. Second, you have to show me that the legs are congruent. So you've already shown me that they're not parallel, that's fine. But now, to prove it's an isosceles, you have to show me those legs are parallel. What about a right trapezoid? A right trapezoid, once again, you have to prove it's a trapezoid. And then second, that a leg is perpendicular to a base. So like we did with our opening problem, I showed that two of the sides were parallel, but I showed one of those third sides was perpendicular to those bases. And you can, once again, you can visually see the fractions. You kind of have a sense, like we saw 3/4 and 6/8. You kind of know what's going on there. Also, by inspection, you kind of see, by inspection, you can look at the picture, the graph, you kind of know what's going on. So, yeah. What's the last thing we're looking at? A kite. Just show no sides are parallel. Show that the upper sides are congruent and the lower sides are congruent. And that's basically it. So I'm not going to do another example because I want to finish this video, but we'll work on it in class together. Okay.